put on this computer, and then I'm also going to share my screen. I'm going to do the full screen, and hopefully you won't see anything overly private, just because. All right. So first of all, let's see what people wanted to go over. If there's anything we wanted to go over, let's see if I can also make a brand new item. Let's do this. And let's see what people are asking. All right. So oh, geez, of course. Stupid templates. I always have to look up the syntax each and every time for templates. So you'll have to bear with me a little bit on this one as well. Let's see if I have, hopefully nothing incriminating. Exam project. And yeah, nothing overly incriminating. Great. One always worries when you're sharing your screen with everyone. Maybe I should actually pause sharing my screen for a time being. I want to see in-class code, and then I will look at the. I should have a short linked list demo just to go over linked list templates. I'll do another templated class maybe, or I could use the one from last week as well, where we were playing around with templating. So let's open this one, and then maybe I'll pull up the linked list template from last week, the problem we were working on last week, and see where we go from there. By the way, and if my sound is not sounding fine, please let me know so I can fix that. Okay, come on, anytime. There we go. Okay, sample exam in question 2. Don't understand what it means. What does it mean, or why we are overloading the not equals operator? So that was. I probably need to make a better sample exam, although you guys have gotten a number of my sample exam, like previous exams that I've done. So those sample exams were designed around the idea that, hey, you have some time, you're reviewing for an exam. It's not a paper exam, so you can actually look up how to do these various things. The not equals operator is an operator. It means not equals to something, just like double equals is an operator, just like greater than or less than is an operator. And you can override those operators. So instead of not equals meaning one thing, it can mean something else. So in this case, a Boolean for an exam should be double quotes, double colons here, by the way. The operator is not equal to, I'm overriding or overloading the operator not equals. And so if you have an exam and you're seeing if this exam 2 is equal to the current exam, and if they're not equal, then return true. If they are equal, then return false. That's what that thing is actually doing. Hopefully I can throw in one of those things for you guys. Okay, so we'll do templates as well. And exams class question. Oh boy, okay. So that was meant to be, so just to reiterate, this was me going, okay, let's come up with some questions for you guys to play with. So I haven't looked at that in a little while. I looked at it recently to see what your questions were, but we could always pull that up, and hopefully not going to incriminate myself too much. Let me stop sharing for a second or pause my sharing, just because I don't want to accidentally, here's the exam. That would be bad. All right. As you might imagine, the sample exam is not going to look exactly like the actual exam because, well, the fake exam was just something that was sort of thrown up there. We have a paper version of the sample exam. Let's regenerate some, unless you want me to look at the, let's actually look at the questions. Unless you want to have me go over my actual solution that I gave, but I'll just pull up some of these things. MVC graph with linked list. Okay, what exam are you guys talking about with exam in it, unless this is the CU questions. Let's see my questions. Function types. Okay. Can someone post something on that? So stack order, review topics. This was just to find out what topics you wanted to go over, but we'll do that now. Let's see what the preview of this thing is. Now, where are you guys getting this? Maybe I'm missing something. Maybe it's earlier in CLearn. Can hopefully, okay. Oh, good that I just answered your question. What the heck that actually is doing? Do you guys want to see? I need to know what you're looking at though with this exam thing, because I'm missing. I might have multiple final exam under fake final exam practice. CLearn. Okay, I looked at that. Fake final exam practice. Fake final exam for practice. I have a sample final exam. Oh, a paper sample final exam. But is that the one you're talking about as well? Templating a special stack. Okay. Is that what we're talking about here? This paper exam. Okay. Thank you. I didn't even look at the paper exam, so let's find out what we have. Okay. So this is me throwing together something 11th hour a while ago, but okay, it's a no duplicate stack. So a special stack with a template. Let me see here. The exam classes, okay. Pivot split, which by the way, if you didn't notice, that pivot split is part of quicksort. So you have a pivot point and you split everything based off of that pivot point. So hopefully that worked for you. Bitmap, it's bitmap class as well. Oof. So this was, I mean, different terms so that we emphasize different things, but let's try and look at this. Okay. So for example, you wouldn't have looked at linked list music because that was something we did in 2019. So I wish somebody had called me on that one earlier. Okay, so let's have a look at this. With exam class, which is stored in a linked list, we'll need a print data and another operator, a function operator, so that no dupe stack can be defined to duplicate a tree. Need to be defined. Okay, create an exam. Oh, okay. Oof. So this would be not something that you would normally do because you haven't looked at a lot of this code. You may not have done in for like exam time. But let's have a quick look at this because I'm looking at what we had here. I have my linked list. I have that opened up already. So we can look at that. The linked list music is going to be the same as a linked list data item. Print data function. Okay, we're going to have a print data function with the exam class, which also stores in a linked list. We will need to define a print data and another function operator so that so it works with the no dupe stack class defined above. Oh, we have a class defined above. All right, so this is a special stack. It doesn't have any kind of duplications. So when I try to add something to the stack, remember what a stack does. It is first in, last out, or last in, first out, as in like a stack of trays. The last thing that gets put on is the first thing that gets popped off. Oh, you're not seeing anything at all. Sorry. You guys, this lack of talking is very disturbing. There we go. There we go. Whoever unmuted their microphone. Do you have anything to say? So here's what we're looking at: templated special stack. This is a templated special stack. It stores a bunch of exams. It has a linked list of exams. Each exam item has particular information on it. So I would be looking at this thing and saying, okay, well, it's going to make a linked list of exams. This is this special stack. I can push and I can pop from the stack. Notice that I'm inserting at the front for pushing, and then I'm removing from the front for popping. And when I push, what I need to do is if the top of the stack is equal to null, as in there's nothing on the stack, or the data does not equal to the top, I insert at the front. Okay. I'm going to need to change that one though. This special stack, presumably, this is a special stack for no duplication. So same element cannot be pushed on the stack if it is already on the top of the stack. For example, if I push A onto the stack BCA, I get ABCA. If I push A onto ABCA, nothing happens. So I can't get AA one after another. I can get ABA, that's fine, but I can't get AA. I can't look at the top of the top of the stack. If it's the same item that I already have on there, it's not going to work. Okay. So what do I need? If the data, and then I need to get the top of my stack and I see if this top is equal to this data. I'm going to have the not equals on, okay, on this kind of thing. This would be this operator right here. This is what you're going to need. So this is my thought process. I'm rediscovering this question myself. So I have the top of my stack. I can pull off an individual exam. So that's what that peak is. It's getting me the top of my stack. I then check to see if it's equal, not equal to data. But notice the not equals operator that's the operator I'm going to be overloading in this case. Do I have anything else that uses data? Return data. You guys can, if you guys have seen this and know what my answer is already, you can let me know. But I don't see anything else in here that uses a function in data. This thing checks to see if they're equal to or not. And I want to override the operator, but there's nothing else. There's not like I don't know if there's a print. I may have to implement print stack, don't I? Yeah, I probably have to implement print stack, which case it'd be another operator. I need to be able to print off what one of these exam elements are. And so I need something that, some kind of function that prints off exam element. So those are two functions that anything that gets put onto one of these exams, and we have this an example of a templated, this is a no duplicate stack that has a linked list that stores different types of data types. That linked list can take almost anything, but in our case, we're saying, no, it'll only take exams, not anything else, only exams. I'm explicitly stating exams are going to be stored on this linked list. The actual linked list code would look very similar to what we did in class. It takes in different types of data and makes a little node. That node stores the value, and then I chain those nodes together. So let's have a look at what the actual question's asking me again. So otherwise the stack's okay, that's fine. So this is the given code to play with initially. And then I might have print data for a function. So something like this. With the exam class, I'm going to make print data function. So it'll allow me to print off what's in the exam class. So let me take one of my nodes and just take my linked list data node and change it so it works with this. But I'm going to have this thing called print data, okay? And any exam with the same course name, not necessarily perfectly identical data. Okay, so the course name is what we're checking on this case. And so this would be the not equal sign right here for this. And presumably print data, if my exam itself is going to be printing off individual elements, I'm going to need print data. Then I'm going to create an exam data structure. And I can store whatever data I want. It must be storable in a no dupe stack. Okay, so I need to be able to implement that not equals operator. Child class, bit exam with additional data that exam implements one new function, whatever new function I want, and overrides print data. Okay, so here we go. That's not what I want, is that? Double linked list node. Oh, that's old school stuff. Let me have a look at this. Oh, it's all commented out. Great. here is my linked list class. Here is my linked list. I should have double linked list node, linked list node. That doesn't look like the right class that I wanted. Let me have a look. Oh, that's polymorph. Why? I don't want that one. I want in-class code. Linked list templates should be the one I'm looking for. Simpler linked list template. There we go. That's the better one. Okay, simpler. Let's go simple. So I have linked list data. This is what we were doing in the term. We know that we're going to add a function called print data. Okay. We know we need to override the not equals operator. Okay. So let's just copy this stuff over and be done with it. And then we'll see where we go from there. Final exam review. Okay. I'm going to make brand new. Where's new? That should be here easily.
So if you right click source files.
I should, oh, it's because I was right clicking the source.cpp. Thank you. I'm going to make a new class and then linked list data. Okay. Just because I know I'm going to be calling it that. Okay. Now we could have called it something else. Here's the header file. Let's see, linked list data. That should be fine. All right, linked list data.cpp. I'm going to be going back and forth with the previous version of this. So there's nothing new that I'm doing here. I just don't want to type all that crap out again. All right, and I'm going to get rid of that. All right, so what am I going to need? I'm going to and so let's also, what the heck? Oh, I need the linked list. I could, if I wanted to, I'm going to leave it alone for right now. So I'm not even going to compile it. Why? Because on an exam, you do not have to have your code compiled. You just need to make sure it looks about right. You don't necessarily get extra points for it compiling or anything like that. It's comforting to know that it compiles. But if you're, running low on time and you're worried about one little thing that's preventing it from compiling, move on. Okay. So here we go. I'm looking at my code here. I got to figure out how to do this does not equal thing. So I'm going to override, and this should be some kind of Boolean operator. And this should be not equals, and this will be it's going to be an exam. Well, these, I should rename everything, but I'm going to call this one linked list data. Data 2. Hopefully that's going to work. I always have to look it up each time, and here is linked list data, and I'm going to override this operator. So linked list data, here's my operator. And what the heck is this actually going to do? This is going to check to see, and what do we say that this thing has to, how do we know if something is equal or not? So it's going to be very similar to what we did with exam. Exam could be whatever you want it to be, call it whatever you want. It's going to look exactly like exam, except for the word exam. It's now called linked list data, but it's going to be, do I have to have a name? Maybe you guys can speak up for a second, but do I need to have a particular name, course name on this thing? Do I need a course name as part of the question? That's what I wanted to know. Because if I do,
I don't remember.
Okay, we're making a course name. Course name, done. Okay. Okay, and SGD. And I'm going to that's going to save that. All of this stuff, I'm going to put the variable course name is equal to BIT2400. And I probably should make it a string. String. All right. So I could have also used a character array if I wanted to do it that way. Okay. Do I need a construct? I have a constructor here. That's what LL data does. do I need a destructor?
I don't think any of those things use dynamic memory, so probably not.
Exactly. No dynamic memory. There's no dynamic array. I don't call new anywhere. I don't call new on making a new object. You could use a destructor if you really need to clean something up, let's say, even if it's not dynamic memory, you really need to, I don't know why you would need to clean something up just before it gets destroyed. It's like cleaning up a building before you demolish it. Really, it's effectively demolishing a building unless you really need to take something out, like take all the people and the pets out of the building before you demolish the hotel, right? That would be why you need a destructor. You're about to blow up the building, clean out the hotel. There's no need to rearrange the furniture. You're going to destroy the building. If you need to get the furniture out, it's different. But a destructor is for when you're going to destroy this thing, you need to get this thing safely out of there.
Now, if we're writing this, can we include like a blank destructor just as kind of a placeholder?
Yep, that would be fine. There's no need for a blank destructor, and some people might balk at it, but I'm not going to fault you guys at all for it, especially on an exam, right? One could argue, hey, you'll notice I get into this little habit of putting blank destructors simply to have a cout statement to say, hey, the destructor was called. I'm not going to fault anyone for putting a blank destructor in there. I'm just saying when you need it versus when you don't need it. But beyond that, you're fine. So great question. Okay, I have this operator. What I want to do is I want to check to see if return. So it's this course name. I don't know if is not equal to data2 dot. Now, here's going to be the problem. Am I allowed to call data2's course name? I think I can, actually. It might be a private member variable, but I think I'm allowed to call that. It's private, but it's in the exact same class. If I'm not allowed to do that, then I need an accessor method. I need a get method, a getter method to get that particular string. I'm giving away something about the exam, by the way. I had to move that thing down to take a screenshot of what the screen looks like. You'll see it tomorrow. So here we go. I don't have a main method. That's kind of useful. Okay, so templates, and then we have operator overloading. I didn't emphasize operator overloading that much this year. It's possible on an exam, but don't expect a long question on it. Expect long questions on the things that we spent a large amount of time talking about, not on something I just sort of blew through. So templated functions, probably not, or at most a question. What did we spend a large amount of time on? We talked a lot about inheritance and polymorphism.
MVC.
MVC was a large amount of time, although more in other terms, surprisingly. Strings a lot more than usual than previous terms. So I didn't do a lot of strings in the first time I taught, like when this exam was made. I didn't go over strings as an object, the string class much. Let me think of other things. We did more linked lists than on other terms, although we did linked lists in all of my terms I've taught this course, but I've emphasized it more simply as a way to talk about these various components of the course. Templating was one. We did doubly linked list. I did that. Let me think here. It seems like I did a lot more of this standard template library stuff. So using a vector, how search works, various, binary search versus linear search, various sorting algorithms, hash tables, that sort of thing was also covered, but not a lot on templated functions. Okay. So int main, I'm going to make a linked list data, data1, and linked list data2, and I need to include that link that. All right, there we go. And then I want to say, maybe I need this. 2, and then the response. This one. So it should be, hopefully that's going to work. I look up this stuff all the time. Is that operands? That should be a Boolean of some form, so that should be fine. Just to make my life easier for a second. I want to figure out if it's the chevrons or if it's the Boolean. It does not seem to be the Boolean. Oh, maybe it is. All right, let's run it, see what happens. Or compile it at least and see if, oh, it compiles. All right, let's see if this works. We're going to find out. What would we expect before we get going? Oh, it's going to be the opposite of that. So that's right. This is saying it's not equal to it. There's no match. So is equal to not that. Not no match. So match. I'm just trying to test my code because I just made an operator that does this not equal to thing. And I want to see if it works. And I'm hoping that it does. And okay, it does work. Great. Why does it work? It works because, well, we can say a number of different things, but this is the function I'm going to call the function that is associated with this operation, this operand. So we're going to call that function, and it's going to pull this thing in for the right as one of the parameters. It makes me very uncomfortable making these operator overloadings. Why? Because I have to look it up each time. I do it once every, even when programming professionally, it'd be like once every 3 months. It comes up, you should be able to recognize it, but don't expect me to ask like the long answer question, make 40 of these things, right? But that's what we're doing here. So if you're close but no cigar, pass it in on your exam. Okay, what was the other thing I needed to have in here? I need to have a print, some kind of print statement, right? I need to print data. So that function is going to be needed. And let's put that in here. So wrong one. Final exam review. Okay, so I'm going to have a print data. Okay, so I have this function print data, and I'll need to go back up here. And print data. And what do I want to do? Well, actually, I'm going to need to use that cout statement. Oh, I would have preferred, instead of using a void print data, to actually have it return a string. Because if it returns a string, then I can pass that into something else. Right? So, but the instructions were, it's going to print something out. So, cout. And I could use standard namespace if I wanted to. That would be perfectly fine. So I could say, let's put in the header file. Hopefully that's will do it. We're going to find out. All right, but I'm going to remove this. All right, so, and then let's put some quotes in here. An exam for course and with, let's make up something here. I'm making it up just in case you're worried where I'm pulling this from. It's out of my nether regions. With what? Blank. So I'm going to say data students, right? It's with this many students or something like that. Oh, we already had a toString. Actually, this would be a, so let's also change this one here and oh, that's even better. I like that more. So, oh, I don't want to do that. How do I want to do this? So if you're wondering what I'm thinking about right now, I already have a function called toString. I have a function called print data, but toString wasn't given to you on your sample exam, but I have it here. So why don't I use the print string, the toString to get a string and then just see out that string. That would be a reasonable approach I could have taken. I'm going to leave it alone for right now, but that would have been a perfectly reasonable approach in this particular case. Instead, I could, let's do this. That would, let's put a couple more cool things in here. That'll do. Okay. And let's look at my source, and I'm going to, instead of all, okay, I can do that one, but what I want to say is data1 dot print data, and that'll do it. I want to check how that works. What the heck? Let's see how that operates. And then I'm going to put a new line at the end of this thing here. All right, let's roll. Course, BIT2400 with 0 students. That's our default constructor, right? If I wanted another constructor, I could put in another constructor as well, to give it initialize it to something. Okay. I have no what the heck idea what the heck. Templating a special stack. Oh, got it. Just getting a response from an earlier comment I got. So I'm trying to figure out where I can help with that. Okay. Might want to, I'm getting private messages from some students here. Okay. So when I'm doing this, for some reason, they think I can answer. Okay. So do you want to look at a template? Let's do a templated function, or do you want to use a templated class? We can do either. Let's have a quick look at what our linked list looks like, actually. That might be the fastest, most efficient way of doing this. So here is me doing a simple templated, this is my data. So here is my linked list.h. Everything is in my header file. Why? Because everything I need has to be in that one file that is being included at the very beginning, because it will make new code depending on what function is using this thing. So I cannot have a header file. I cannot have some declaration, function declaration, floating around and having it being divorced from the CPP file. The CPP file has to would have to make a brand new CPP file and a brand new header file. Effectively, when I am, using a linked list and I'm putting an exam on this thing needs to make a brand new class called linked list that happens to take in exams, right? Linked list exam. It's going on behind the scenes without you knowing it. The compiler is building a brand new class called, linked list exam, or linked list with some crazy number behind it, that will only store exams. And if I make a linked list that stores something else, it will make a brand new class that will store that other thing. As a result, everything has to be stuck in the header file. As a result, it also means it's a pain in the ass to write these things. So it can be problematic from time to time. So here we go. Top line, I'm saying I'm going to have some kind of type name, some kind of class type name. I think class also works there as well. I think they just changed the syntax standard a little bit recently. But I'm going to make this class has a particular type of data that it stores. Type T. What's T? I don't know. It's just short. It's easy for us to write. It's like I for counters with for loops. So, and all I need to do is say, I'm going to take in some kind of data T, and everywhere where I normally put in the exact type of data there, I'd say, hey, it's T. I just keep on putting T instead of putting like exam here, here. Everywhere I have this T, I'd put normally the word exam and it would be perfectly fine. The type of data being returned, it's a linked list node that stores type T. It's just everywhere I'm referring to that particular class, I need to say what kind of data it stores in there because it's going to make a new version of that class each and every time for every type of data that I put in there. So really the big takeaway is I can write my original code and then I just sort of hot swap it. And instead of saying linked list node by itself, I say linked list node that takes the type T and I put T's everywhere. And at the very top, I say, by the way, it's a templated class. That's it. The issue with this is you don't find your bugs very quickly because it's going to generate new classes. And so it doesn't give you this nice autocomplete that you would get otherwise. My normal solution is when I'm writing something that I know is going to be a templated class later, I write the code in sort of the vanilla form that it's going to store exams or it's going to store linked list data or it's going to store a particular type of data. And then I go through after, once I know it works, I know it compiles, I then template it because you can't catch your bugs remotely as quickly the other way around. So that's just my approach, but it seems to have been serving me pretty well so far when it comes to that. Does that answer enough about your templating issue, Beth? I think it was Beth that was asking about that.
Yeah. So like, is there ever a point where you say like the template is going to be this, or is it just going to handle that by deciding based off the context, like, okay, it's going to be a string now. And you said that that makes it a different class every time?
Yeah. So
Okay.
I make I can make a linked list that stores in, let's do that. So I have a linked list node here. Let's see if I have an example of this. My tester might do that. There you go. I'm making a linked list that stores LL string data, and I'm making a different linked list, which is a whole different class in the end, that stores LL data, a different kind of object that gets put in there. And the only way you know that it'll tell you when you do it wrong or not, if LL data or LL string data does not have a function that you need. But if it has the functions you need, it's perfectly happy to accept that kind of type of data. So
that's just a lot more vague than I'm used to C or C++ being. So it's
it's kludgy as hell. Yeah, it's completely. I remember looking at this going, no. I think I learned templates at some point in time. Forgot templates. Learned Java templates, which seemed to make a lot more sense. They're a lot less crazy pants. And then I relearned C templates like a year ago or two, more than a year ago, but not that much before the start of the class again. And I remember looking at the documentation going, no, that can't be right. No, it's right. It's kludgy as hell. It's them trying to sort of retrofit C++ to allow different types of data being stored. And as a result, it gets you this kind of weird behavior where, yeah, you can put whatever you want in there as long as it matches their criteria, you can put it in there. So what we've seen with Quicksort, for example, the criteria is whatever kind of collection of data goes in there, it has to be able to compare one element to the other using a less than operator. Not a greater than operator, less than operator. And if you have that, it'll accept the data. But if you don't have the less than operator, it will not accept the data. Which just, yeah, it seems a little odd. And it is kludgy. I mean, cobbled together, sort of duct tape and a prayer, MacGyvered, if you will. It is trying to retrofit an old language, but it does the trick. And most people don't actually have to write a lot of templates. You should be able to use a template fairly easily. Writing your own templates, okay. I don't tend to have like 40% questions on an exam with writing your own template, but I might give you something that is a templated class, like linked list here. If I gave you that, then you should be able to use it, right? So can you use a linked list? Well, all I needed to do for a linked list was I said what kind of data goes in, and then I added the data. I called print. Oh, I don't have to do anything else. I have to do for when I make my linked list initially, I say what kind of data goes into it, but that's about it. The rest of it's just, I use it.
So if some of the data types are incompatible within the class, where you try and say like this, I'm going to try pass this in, like if everything in your functions and stuff requires numbers or something that is like easily convertible to numbers, if you try and stuff a string into it, it might break.
Yeah, it won't let you compile. So let's see if I can do this. Maybe I need to do STD. I think it worked last time and I was like, no, it works. I think it actually works. Oh, no, it's because it's LL. It should be 3. Let's try 3. Get value is not in string.
Okay, so
Yeah.
okay, so that's reasonably predictable if you know how the data works.
But you need to know how the data is actually working, right? That there is a function called to something called get value. If that wasn't there, yeah, it would merely let you take in a string or an
And
integer.
if it was like a C string, it might compare it and then do it in a weird way that you don't really.
If it's a C string, it's not even an object, and you can have templated things that allow you to take in integers, for example, but those
Yeah.
integers happen to have like a greater than operator, less than operator, that sort of thing, but they don't have a function call like get value. So you couldn't put
Right.
in a C string for sure, because if you have a function in there, you need that function to have, you need a function called get value in that object.
I mean, like if you're making a different kind of template and you've got it so that it's compatible with ints, you might be able to stick a character string in it, but the way that it's going to behave might not be what you expect because it's like comparing the values and their letter values. So
It'll be worse than that. Single
it's
character versus an integer would be
yeah,
comparing character values, and absolutely it would be that.
the other one's an array.
If I allow a character string, what's it gonna compare when I compare 2 character strings? What does it compare?
I think just well the pointer.
Yeah, it's a pointer. It says, is this address before this address in space? Oh, in that case, it comes first. That makes no sense. It makes sense, but it's not really useful, right?
Yeah.
Arranging people in the class based on, shirt color or something like that, or I don't know what something that would be completely useless and doesn't really give you any information what color your shirt is, right? Versus like if you because you're just comparing 2 pointers, you can see if they're the same thing if they share the same pointer, but other than that, right, knowing which pointer comes before the other one makes no difference in the world really. Nice. Yeah,
It's just an arbitrary memory space.
Yeah, pretty much. And so that's why that's why you can actually sort arrays of integers, and you can sort arrays of characters, and you can sort arrays of this, sort arrays of that, because they all implement the less than operator. You just don't know that integers implement the less than operator. You get it for free. All right. That was, some people may have gotten a nice little panic attack as a result of this. We're not going to go overly crazy on this. The idea is a template. You can look, if you look at if I go into, let's say, linked list.h, and I go through this and I find something that has like some value t of type t. Let's see, I think I have one in here somewhere. Get next, add, okay. Contains, remove, get previous. I'm pretty sure I have it in here. Print list, it's probably in here. Okay, there we go. So what's p current? P current is, so I have a linked list node. That's the head of that linked list, with currently the head. Then I'm going to call toString on that thing. Get next. Okay, that's not going to do it either. Let's go through linked list node, another templated class here. Okay, it's taking my data, whatever my variable, the type of data that's being stored in there, and I call toString on it. I need a function called toString. Every single data that gets stored in this linked list has to have a function called toString. I need, and here's my other one, I need some kind of function called getValue, no matter what. If I don't have those two functions, I cannot store it in this linked list, because it's effectively saying what could fit in there. I'll let you know. I'll know when I see it. You are saying, can I put this thing on your list? And it goes, well, can you call this function? Can you call this function? Then get the heck out. But until that point, it doesn't know what it wants. It knows whatever gets stored in this thing needs some function called getValue and some function called toString in this particular example.
So in this case, it's probably only going to be things that use strings.
Nope. Here's linked list data. It has a function called toString though.
Right.
So it can convert it to a string. It takes an integer, converts it to a string.
Right.
But I would need to make sure that that is implemented.
Okay, so you can make your own toString
Yep.
function and just use it instead of the standard
And that's why we
the
needed
string object toString.
And that's why we needed to implement that that not equals operator, because it was calling not equals. And if I don't implement that, it doesn't know what the heck, it can't store it.
String has its own
Not
operator overloads.
Yep.
Which was confusing.
Including toString. String has a function called toString, which effectively does nothing. It just returns itself. But all right, I want to make sure we're into really interesting territory. I love these conversations. I want to make sure that the people that are panicking, going, what the hell are they talking about? Are they speaking English still?
Yeah, because templates, he said, weren't really going to be that important for the exam.
They show up on the exam. They don't show up as an 80% question or like half the exam, right? Inheritance, polymorphism, making an object, those are key, topics of for an exam. Let me think of other MVC events. End up being semi-important, but not like be all and end all. We haven't tested any of the standard template libraries, anything about stacks, stacks or queues or hash tables, or we didn't do heaps. Sorting out, I already said sorting algorithms, but that sort of thing we haven't touched yet, because exam 2 covered a lot of that material already, but I can still ask stuff from exam 2 and before. But the new stuff after exam 2 is templates, data structures, some data structures, sorting and searching. I think that's it. By the way, you'll get data structures again. I think most of you get data structures again later. Do you have a data structures course afterwards, or is it just David Tui's class next?
I'd have to check. We have data management this term, and we have statistics next term. I think that's our mathy course next term, and then we have intro to like game design for video games.
With David Tui, right?
I'm not sure.
Spell like Thu.
Oh, that sounds familiar, actually.
Yeah, Tui. It's even a made up name by his family, supposedly. Anyways, so yeah, that's your programming intense course.
Yeah. Oh, you're saying it's got a lot of programming. Okay.
Yeah,
I think one of those actually does have programming as a prerequisite.
Yeah, that's his. Stats wouldn't require it, but his course would. Okay. Iterators. Oh, geez. Iterators, my least favorite thing. Thank you, Julia. Okay, I can go over the concept. I always screw up my iterators. Okay, so the idea of an iterator. Let me figure out how I want to say this. Okay, if I have a stack or a queue, but let's say I have something different than a stack or a queue. Let's say I have, I just want a collection of elements. I don't care how it's stored. I just want to be able to get from element to element. What I don't want to do, and there's this weird art form that programmers have, and honest to God, it's not me making this stuff up. Really, it's not. Seriously. There's this art form of giving someone a tool, but not letting them know how to use it, or not letting them know how it's built. It would be the equivalent. Let me see if I get the good example in my pocket. There's one. There we go. Not the best example, but here's one example of that. Your cell phone. How many of you jailbroke your cell phone? How many of you have figured out how everything inside your cell phone works? No, you're supposed to treat it like an appliance. Some of you may have, but it's supposed to be treated like an appliance. It's supposed to be, it does a job, it does something. That's about it. Here is the opposite. I don't know if you can see what the heck this is. This is, I think, a first or second generation Raspberry Pi. This is a little computer that you're supposed to pop open, plug crap into, catch it on fire. It costs $35 essentially, and you're supposed to be able to solder things onto it and stuff. It's meant to be played with. Very different philosophy on this thing, right? What an iterator does is it wants to hide how things are built. It wants to hide the man behind the curtain, if you will. It wants to hide how everything's put together. So I have this iterator that I can just say next, 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 next. I don't want to know how it's put together. If I have an array that it's going over, or a linked list, or whatever the hell the case is, I want to be able to just go next, 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 next. I could put an iterator onto a tree if I wanted to. And so I go next, 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 and it has a particular order. It would traverse the tree, getting the next element each time. I don't want to know that's a tree. I don't want to know how it's put together. I don't want to know how much data it uses. I don't want to know anything about it. I just want to be able to go through my list or go through and get all the elements. So however it's stored, I should be able to get the next, get the current, go to the next, figure out when to stop. That's what an iterator is for. So every one of these data structures, if I make a linked list and I make an iterator for it, it allows me to hide that factoid, how the linked list is built up. You should be able to call it foo or David's awesome collection instead of a linked list. Call it whatever you want. Call it Susan. And it still works. You can still use it. You don't know how it's put together. That's the philosophy. So my iterator, let's figure out what my iterator would be over. I don't have a linked list there. So let's see if I can make an iterator here. My iterator, it has to know about how linked lists are formed and stuff. It needs to be able to get the next element. But something else has an iterator. The iterator has a particular look and feel to it. And you can just use it and you're blissfully unaware of how it's doing things. Now, there's always a little screw up in my iterator implementation, which is why I'm sort of been shying away from it. Let's see if I can get it off the ground at least. Do I want to do it as a templated iterator? Because linked list is templated, I might have to make it a templated iterator, but I'm going to leave it alone for right now and just try to do it the normal way. So I'm going to add a new class. Now, I should call it just iterator, but all iterators have sort of a look and feel to them. Okay, and that's fine. They're going to need to know what they're iterating over. So they need to know about linked lists. And oftentimes you'll just make them a friend class of your whatever thing you're using. I didn't do that last time because friend classes are considered somewhat bad form, but we'll leave it at that. So include linked list.h. Okay. And so what do I need for my iterators? I'm going to need a constructor. I'm going to be able to need to get next, current, and maybe I also need to has next, let's say, something like that. Whether you give me an array, whether you give me a linked list, or give me a linked list, or whatever I'm traversing over, those functions will still work. And no one needs to know how things are put together. I'm just calling get next, get the current. Does it have another element? And the idea is that I could make this a linked list, an iterator for an array, or I can make it an iterator for a linked list or whatever I want. So let's actually make it for an array temporarily and then go from there. So make that public, private. I'm going to make this, it's going to be an array of LL datas. Okay, so it's an array of LL datas that I'm going to be making here. And I want to pass, this is where I get a little weirded out by this. This is the one place I'm going to break my encapsulation. Okay, because I'm going to set things up here. Next, okay, and then it's going to take in LL. I'm going to have a void. Get value. Boolean has next. And if I wanted to, I could also perhaps get the size of this whole thing, but I don't technically think I need that. Okay. Okay. And LL should have been capitalized. There we go. That should have done that. Okay, so a data is equal to a my data. It's going to change the pointer. So I'm pointing to this array that I have here. Oh, I'm going to need the size of the array. Do I need the size of the array? Let's just for argument's sake. Okay, and a size. Okay. So I want to know how I'm going to need to have some kind of iterator for where I currently am. The iterator can actually have that. So current pause is equal to 0, let's say, or I'm going to not set it to 0 first, but I'm going to set it to 0 after in my constructor. The starting position. Okay. If cur pause is less than size cur pause plus plus, move my position where I'm pointing, where I think I'm pointing, moves over. And I'm going to need to put this iterator thing in here. Boom, boom, boom. All right. That less than size, is that going to do it for all our cases? If I get to the actual size of the array, I'm past the end and I can't get anything back. Has next would be, I want to think about that part a little bit. I want to do the math so I'm not off by 1. Do I have a next element? So it's I can return current position is less than the size minus 1. That's probably the better way of saying it. If I'm at the last position, if I'm at the very last position, there is no next. Does it have a next? No. So if the current is less than the size minus 1, do I have a next? Yeah, I do. Okay. And then I can get the value, which is I'm going to return a data at position, current position. Okay. I just made an iterator. I don't know what I'm iterating over, but I can make an iterator. I have some kind of data structure. I don't know how it's built. And I can just go get the next, get the next, get the next, get the next. I can have a while loop that will traverse this entire thing by just going to the next element one after the other. So let's do tester and new LL data of size 10, let's say. I'm just making something up here. Okay, LL iterator, and you're probably wondering again, oh, I need to include LL iterator up here. Okay. Oh, I need to include a data and 10. All right. And then I can have a while loop. Let's say while iterator. Oh, that's going to be a pain to write. Let's have iter. I'm just being lazy. I don't want to write iterator every single time. Iter dot has next. While it has next, I'm going to see. I think I need to do it this. Oh, I can do this. Okay, iter dot get value dot to string C out. So this is going to be all right. All I'm doing is printing out what the first element I have, the value that I'm currently pointing to. And then I can go iter dot, if it has, oh, I should get the next. If it has a next. Next. Actually, I don't want to do it that way, do I? If it has next, I can just increment it, but I'm going to miss the first step. Let's leave it at that at least. So what's this going to do? It's going to check to see if there's another element. If there's another element, then I'm going to go to the next one, print off the next node, go to the next one, print off the next node. The whole reason I'm pointing out all of this, and hopefully that'll build and be fine. Oh, current position. Oh, that's why. There we go. Was it the name of, let's see what, my data, that's data and, oh. In case you're wondering what the problem is.
That problem.
Right, that problem right here. Nice. Thank you. The problem I introduced on purpose and then forgot about. Yes. Joy. This is one of the dangers I find when I program. Okay. If I run it, I should get something about the 3 or however 10 things. Let's see. There we go. Linked list data 000. This is my linked list thing that I was doing. It's these are the LL data items that I just stored in that and use the iterator. I have an array of these linked list data items, and I use my iterator to go one after the other. The reason I want to bring this up, let's go back to iterator. Iterator right here. Let's clip this off. Let's clip this off. Let's clip this off. and linked list. Okay, there we go. And let's go to my iterator here. This is the one place I would need to change stuff because it's going to take in a, I don't think even needs to, it does need to take in a linked list. And let's make a pointer to a linked list. All right, save that. I'm going to comment out all the old versions of things. PLL is equal to P new linked list. Every time I think I'm going to get autocomplete there. All right. How do I get the next one? I go, I'm going to also need to know where I am in my linked list, right? So I should keep a linked list node around. Iterator. Actually, let's see what linked list gives me. So if I have PLL, what do I have? Get index, get size, contains, add, print list, remove. I will actually want to keep my linked list node around, and I'll use that. Okay. And I'm just going to use the node to walk down this list. Okay, so let's kill that. Current node. All right, so I have a current node, and my linked list iterator is I want that. Do I have a current node here? I may not be able to get the current node. It might be a private method. I have to change the linked list. If it was a friend class, I would be fine with it. Let's put it in the linked list node. Get rid of the linked list. No. Okay. The next is going to be if p cur node do I have it? Huh. Something like that. Get the particular value. And so this is p cur node. Get data. And then this thing right here is return p cur does not equal null. And hopefully, I'm going to have to change my tester as well. I'm not even using this at all. So linked list node. Let's leave it in there. Okay. need to change this one. Oh, I need to say what kind of linked list it is. And what kind of linked list is it? It is an LL data linked list. Okay. So semicolon. Something's wrong with this. I thought this was going to be much smoother than, oh, that's why. Let's just copy this. It's going to fail out on tester here, which I knew that was going to happen, so that's fine. And so what do I want? I want to pass in linked list and my, what am I adding here? Oof. This first element of the linked list, which I'm not sure I'm going to be able to get. Okay, so let me, rather than refactor all my code here, I'm going to need to be able to get the first of my linked list or ask linked list for that information, because otherwise I can't get the individual element. Or I need it to be a friend function. I need to be able to get access to its member variables. But the point being, if I got that up and running, and let's pretend I can get it up and running, I'd have something like a linked list data here. Oh, let's do, that's what we can do. Start is equal to this. And then I'm going to have ll dot add. Is that going to work for me? It's going to be a copy of it. It's not going to work. Okay. I don't want to get too, I'm already in the weeds. So here's what the plan was. The plan was before I realized that it's going to go off rails here. When I use an iterator, other than the last little tiny, the last step on this whole path, I've made an iterator for a linked list that should walk down that linked list. Or if I made an iterator for a tree, it walks down the tree. Or if I made an iterator for an array, it goes through the array. You do not have to know what the data structure looks like or how it's put together. You don't want to know how it's built. You just want to use it. And an iterator allows you to get the next to the next, to the next, to the next. Know when to stop because it has a has next. Is there any more left? And it allows you to get the individual elements you need without knowing how the data structure is built. It leaves you this level of abstraction, so you don't have to worry about how it's all put together. That's the point of an iterator. And I'm going way too long here. Sorry about that. All right, let's see if there's, I can't seem to get my chat window open here. So let's see if I can, I'm going to stop the screen share for a second. There we go. So it shows up. All right. I know this is relevant right now, but what should we use the namespace? You can use the standard namespace. It ends up getting, it is more work to write STDs. Nice point, Chris. The only reason I do this is because I'm also getting a little lazy, and if you're using standard namespace in some files, but not in other files, and on a Tuesday, it does this. That's the reason. It's, if I include it in the header file and then I use another namespace for some other place, it gets a little wonky. If I don't say it's standard namespace, then I just put that std : and I know it's going to work. So that's purely me being like, it's like me using this everywhere, right? I'm lazy. I get autocomplete with by putting the word this in there. With avoiding collision. Yep, it's a huge library with built-in functions. Sometimes you can get a namespace collision, and some people swear by never using standard namespace as a result of that collision. Just the same reason why you don't include all of your different files every single time. You normally have one file that does all the including for you, so that you don't have to do it over and over and over. Like you have one file, you include that one file that has all the other includes inside of it, which I think you've seen in the model view controller. There's one file that has all of my include instructions in there, one place, so that I don't have to go like, oh, but I have to put it in this order, and then this one does it in this order. Everything's included all in one go. I just include that very first file. Do you need to pass the exam to pass the class? I love that. I don't love that question, but I also love that question. It's a theoretical yes. It's a theoretical yes, because if you get a 49%, I don't fail people for 49%. It's there for cheaters. And it doesn't make as much sense this term as it does in other terms. In other terms, the easiest thing in the universe for us to do is to say, it just happens that your assignment looks exactly like Bob's assignment. Okay. And then you get to the exam and you fail hard, and then you go, well, but I should have been able to pass. And you go, no, you got a 12 on the exam, right? You may have had a 90% on the assignments, but you got a 12 on the exam. The one place I could monitor you, make sure you didn't cheat. I can't monitor that well on this exam. And on top of that, we're trying to be sympathetic as well. So that policy probably won't be applied. But if you get a 12, expect to fail almost whether you fail the rest of the class or not, right? But if you get a 48, you're fine. If you get a 40, you're fine. I think I went down to like 29 at one point in time, where I said, like, that's the line. If you got a 90% beforehand and you get a 29 on that exam, you either had a really bad day or, right. So probably won't be applied this time. Double pass with flexibility. You need to pass the course, yes, and pass the exam. Yes, a double pass. Yep. With flexibility. Yep. Get used to disappointment, maybe, because I don't think I get 100% of my own exams. It's hard, right? I'm not going to. People maybe think I'm trying to be a jerk about this. I'm not. I just know what you're getting with David Dewey's class after this. And he was very impressed when he got the 24. My former 2400 students went to his class the next term, and they're like, oh my God, they're doing as much as the 4000 level, like the fourth year students were doing, because you guys got up to speed. He was amazed at how well you guys were. I'm very impressed with what you guys are able to pull off. I know it's stressful, but it's hard. So can I answer additional questions? I know I'm going long, but I have a meatloaf in the oven. It's supposed to be 2 hours. So any final tips for the exam? My big thing, it depends on how you like studying for exams. Well, maybe no one likes studying for exams. I've strongly suggest don't just rely on, hey, I looked at the PowerPoint slides, I'm good to go. Math, computer science, and piano, or a lot of things in this world require practice. And so if you've been practicing all term, you don't actually have to do that much studying. If you've been practicing doing the work all term, like doing the assignments, review, like glance over the assignments, the kind of things that you did to go like, what kind of topics was I confused by? Do I understand what a template is? Okay. Do I understand what a hash table is? But I'm not going to be saying, give me the definition of this. It's an online exam. You can look it up. I mean, it's ridiculously easy to cheat in that case. Do I understand what these linked list things that I've been showing all term were? Right? Because that seems fair game. It's about applying things, and you're not necessarily going to get 100%, but if it doesn't compile, still pass it in, right? But if you've been doing the practice all term, you're probably fine. If you haven't, you're probably not. Yeah, the right examples normally. Yeah, and if you don't remember 100% of things, my line, the reason even on the online exams, I'm suggesting a cheat sheet is because it's a forcing function essentially. You write a cheat sheet, and when you go, oh my God, I'm going to forget this term, you put it on your cheat sheet. And then invariably, because you put it on your cheat sheet, you don't forget it on the exam. People never look at the cheat sheet in the end. Emily, do you have a question?
Yeah, I was gonna ask. In a lot of exams before, you relied on a past assignment. Are you gonna do it again for this exam?
I can neither comment nor I can neither deny or confirm or deny that particular report.
Okay.
If it works on either past assignments, past in-class code, that sort of thing, if that would require you to keep up with class and actually watch the videos for class and actually do stuff in class. And it also means if you send your thing off to Chegg, and yes, I know about this. If you don't know about it, don't look it up because bad, but there's online resources where people essentially can send their exam off to some other person as tutoring, and they answer your questions for you. And we monitor these things. It's a lot easier to prevent that from happening altogether than it is for proving that you sent it off to some random website. So the easiest thing in the world is you make it so that it's easy for someone that attended the class to pass the exam and freakishly hard for even a fourth year student to come back and do the exam. You make it so that people that attend the class have an easier time with the exam than other people. That's at least the intention. If I don't hit the mark, well, I'm sorry, but that's what we're aiming for. Yep, then you're perfectly acceptable. So not everyone can see all these things. If we wrote something on the exam from previous solutions that was provided by you, or was in the slides, would it be acceptable? Yeah. And the easier thing to say, as provided in this, right? If you take, let's say I say, this is going to be a stupid question, write a linked list. You go to the sample code, you grab my sample code, you dump it down and say, as provided by Professor Sprague in a comment or something like that. So you're covered your ass. You clearly stated where it came from. And on top of that, I'm asking for something that I should know that you readily had available to you. So yeah, absolutely. If it's as seen on Stack Overflow, no, you cannot use that. But if it's from the class, it was given to you as sample code, then it's perfectly fair game. If it's anything from the class, it's fair game.
Another question. So I have another question.
Sure.
You mentioned a template. What sort of template were you referring to?
I'm wondering what the question when I refer to templates. My memory is like that of a goldfish right about now.
You said templates, hash tables, linked lists in one sentence, and I don't remember what like a template was.
Okay, so a templated linked list or a template linked list. So a template meaning it can take in a wide variety of different data. So let me do the screen share thing again. And my wife's yelling about something or other over there. She has another meeting at the same time. Is this, yep, there you go. So this is a templated or template linked list. If you see that there, it can take in data of a variety of different types, as long as it fits the template, right? The template of a university professor. What do all university professors have in common? Well, they're sort of absent mind or whatever you want to call, right? They drink the tears of the youth, and they love making people suffer, usual professor thing, right? That would be a template for all university professors. They're absent-minded perhaps, or whatever you want to use as the insult, right? You use the term template all the time. It's the template for the kind of person I like to go out with, the template for the type of class that I like to do, the template for the type of activities I like to do. I have a template for the kind of video game I like to play. I like playing turn-based role-playing games in particular. So if you give me a turn-based role-playing, not all of them are going to fit it, but most of them have certain key things that check off the boxes, if you will. That's what a template is all about.
So you said template to accept anything. or like only anything within the parameters of the template?
that
So-
that fit the template. So
Oh, okay.
so something like this thing, it wasn't that one, but in the sample exam that you guys were talking about, the not equals to operator, it fits the template because I know whatever object I have there has to have a not equals operator. Otherwise, it won't accept it. It doesn't fit the template. It has to. Sorry.
No, that makes sense. So,
There you go.
hash table of linked list. Right. There are like two types of linked lists, right? There's one type where it only goes one way, and one type where it goes like forward and back.
Mhm.
So what was the one that only goes one way called? Is it just
Linked
like a
list.
normal link? Just linked
Yeah.
list?
Just a linked
Then what?
list.
Then the other one, it's called a double linked list?
Doubly linked list. Yeah.
Okay.
And the only reason we did the separation of the two, why we discussed both different types, is because it makes a really nice example of classes and hierarchies, right? A doubly linked list is a child class of a linked list. You get all the original links, and then you add the other links.
Child linked list. I'll just write that down.
Just like a BIT student is a subclass of Carleton students. They're just like Carleton students, but they also have Algonquin courses, right? You have an Algonquin, you have a Carleton number like every other Carleton student, and you have an Algonquin number, right? It's there is a slight difference, but you are a subclass or a child class of Carleton student.
So a double linked list, it's just like a linked list, but it has an extra link that links backwards.
Yeah, you have a previous and a next. For each node has a previous and a next. And on top of that, so it's not like a conga line, it's you know who's behind you, you know who's in front of you. I guess you do that with a conga line, but let's pretend you don't know who's behind you. And besides, a double linked list also has a head of the linked list, head of the list, and a tail of the list. So you need to know. There's also circular linked lists if you want, right? All sorts of crazy things you can do with these things. Circular ones would be the last one connects to the front of the linked list again. You just need to know where the end is so you can know when you looped around. But you never get null at the end. You just go around in circles.
But in a normal linked list, the head and tails, I mean the tail points to null.
Yep.
And in a double linked list that's like normal, the head points to the one in front of it, but also points to null behind it.
The previous is null. The next is something. Presuming there's something. Presuming the head and the tail are not the same.
Okay.
Right? Because if it's a one element linked list, there's nothing before or after.
So template type name. What does type name mean? Like you wrote it down a couple of times. Template type
It's just the keyword for, it used to be class for this. It's just to indicate that it's a template.
Okay.
So the type name is T. So everywhere you see T, that's that generic something. Something's going to go in there. What something? T. That's what that's all about.
T is a linked list or T
Pillars
is
of Eternity. I haven't played it yet. It's on the list. Sorry, Emily.
So the type name T represents a random linked list or a random link?
Neither. It's a type of data. It's a templated type of data. LL data fits the T description, right? It's the template. That whatever data you put in there has to sort of fit this description. Like linklet LL data fits the description. T is just like something. Some kind of data is going to be stored here. What kind? Something. And then you can figure out what it is based off the temp, what kind of functions are being called.
Okay.
Yeah, I actually knew that as well. That's why it's on the bucket list. Although I also have Divinity Original Sin to that I just got for Christmas. So I'm not going to have any exams or anything worth a damn next term. It's going to be just garbage. It's going to be an absolutely garbage course. If you thought it was garbage this term, words can't describe how garbage my term is going to be next year because of divinity. I'm joking. That's I'll ignore my kids in the summer instead. So Chris, to answer your question, is it harder than the previous one? It's a hard thing to answer because I never actively try and punish students, if you can believe it. I honestly don't, but it's very hard to hit the nail on the head. So the last one I think was too hard given the grades.
Really?
Well, the grades were not that, the average wasn't that high.
Oh, okay. Well, at least I did good.
Yeah.
Ah.
So, and some people will do. Yeah, a lot of people will do really well, but some people will struggle at that. But I'm aiming, your average class is aiming between 65 and 80 is sort of that normal range that you would aim for a class for your average, and presuming a normal distribution. Yes, we can get into stats if you want, because Beth, I know you love stats. You're going to have all sorts of stats soon. But assuming a normal distribution, 65 to 80 is a proper range. If everyone gets in the 80% range, I get in trouble, and they'll actually scale down your grades if everyone gets in the 80% range. If everyone gets below 50, I get in trouble again, right? It's that they're trying for a particular distribution, and you can be off, but you're aiming for that. Yeah.
So, I'm gonna assume that the exam is going to be the same-ish hardness as the midterm.
Aim for that, yeah. And if you get pleasantly surprised that it's easier, great. If it's harder, then you'll be pleasantly unsurprised. But I'm hoping not to be give you something pleasantly unsurprised. You can expect it to be longer. It's a 3-hour exam versus an hour and a half. But it's
damn, I didn't know that. I thought it was only an hour and a half.
No, it's a final exam, so it's 3 hours. Yeah.
Okay, that makes me worry because no, it's okay. I'll figure it out. I had to ask. So if everybody gets 80 in a class, do they make the course harder or like what?
The instructor can get in trouble, but depends on the university, or depends on the term and the regularity. And it depends on the term, depends on the class. So 4th-year students, it's not a big deal. 1st-year students, big deal, because what you end up getting is they'll give away A's like they're candy if otherwise, right? If all you need to do is make the students happy, and the easiest way to make all your students happy, which I definitely do not do, it seems, right? If the easiest way to make all your students happy is just give everyone an A, which leads to when you get to 3rd year, you fail out, but that's not that's not that instructor's fault or problem. That by that point in time, they're out of their hair, right? You made them happy, you gave everyone an A, everyone passed the course. The students are screwed over later, but and so that's what they're trying to avoid, is just giving away too many A's. If it's a legitimate, this class is brilliant and nothing I did drop their GPA, that's a different story, but that doesn't happen very often. It's normally you made it too easy because you're trying to make them happy so that you get good student evaluations. So yeah, they're trying to prevent instructors from gaming the system, essentially.
What happens if it's a super easy course, like I don't know,
nature with Michael Runts?
Is that an actual thing?
Yes.
I will say my favorite story I like telling students, and they're sick of it. My lowest mark in university is in a course called Plants for People. Honest to God, I had to do an all-nighter, and I loaded up on caffeine, and I found out that is the dumbest thing you can do, just as not unsolicited advice. Staying up, being sleep deprived, and being loaded full of coffee does not make you write smart answers. It means you think you're writing smart answers, and it's like you're drunk. I looked at my exam after, and I'm like, doesn't even make sense what I wrote down at the time. It makes no sense. The best thing, good night's sleep, and getting ahead of this and studying advance is one of the biggest things. So make sure you're not killing yourself, trying to study and study and study. If you've been doing work all term, you're fine. If you haven't, well, that's a different story. But if you've been doing work all term, there's no need to really cram. You can skim over your stuff again, make sure you know what you're talking about, and you're good. Which will it be per part? I'm not going to answer that. Plans for people, what kind of course is that? It was a biology course. It was meant to be a bird course in biology at Queen's University. That one term, they decided to make it hard, for one thing. And I was sleep deprived, and I put everything on the final exam, and it was just bad news all around. Computer science is one of the wonderful, I know you're not doing computer science, but we're still doing programming. One of the beautiful things I love about it, and maybe I'm biased, I am biased, is that your when you go and do your exam, you really don't have to do that much studying at the end. You don't cram for computer science, which is a blessing and a curse because it hurts like hell throughout the term. It hurts like hell every single year. But for that, when you're studying for the final, it's just like, yeah, I've done the work, I'm good. Because it's not a matter of cramming stuff in your head just to purge it out later. It's a matter of you've done the practice. It should feel natural. You just do the work. It should be. My first computer science class I ever took. The textbook didn't crack on that one, like my physics course in high school, but I didn't study at all for the final exam. Effectively, I think I glanced over it for like a couple hours, maybe at most, and I got my highest mark in university. You can't cram. You do it, and if you're doing the practice, it will come naturally. That's the unfortunate or fortunate thing. You can still study for sure, but it's not a matter of memorization and cramming things in. It's a matter of did you put in the time and the effort throughout the term. Same with math. You can't, I mean, you might disagree, but real math, you don't doing a proof, you don't cram how to do a proof. You practice enough that it becomes natural, then you can do a proof on an exam.
That's why
I
I
have a
hate math.
question. I have a question.
Sure.
So my question is, the model view control thing. Is that on the exam? Like, should we
Can't
study
say
for
one
that?
way or the other. Model view
Okay.
controller is fair game on an exam, though.
Okay.
And the MFC, Microsoft Foundation class, absolutely not. And some people will be, I wanted that. What are you going to do? Memorize what to put on there? Like it's open-ended. It's fun to look at, but I can't ask a question that tests whether you understand something or not. I can with model view controllers, right? So what do? We refactored it. There's a lab where we said make a new object, but I would have to be very, very specific on what kind of new shapes. So refactoring is fair game. I could say make a triangle shape, but here is another thing that looks, or make a pentagon shape or a hexagon shape, let's say, and here's how to put a bunch of points in there. Like I'd have to guide you because I can't expect you to come up with some things on the fly. I'm not expecting you to come up with how to draw a line in Windows, but I'm expecting you to know what, mouse events look like, right? What does a mouse event do? Or that we have mouse events that are being done, that there's a paint event, that there's these different events that happen. Yeah, I mean, if I was spending more time with it, and I would wish I did spend more time with it, I'd be doing things like timing events. So you'd have animations. Like one of the labs has this rectangular shape that animates, right? Because we have a timer, and an event timer goes off, and you update the position of your animation. You update your model. The controller updates the model, and the model says, "Hey, redraw yourself." And then the paint method gets called, and you redraw the shape in a slightly different size. That's the idea of events, refactoring of code, and sort of separation of concerns are what we're really aiming for.
Hi, just to make sure I totally understand the idea of hash tables correctly. For a hash table, they just come up with a random position for the whatever you're putting in, right? Like it's just randomly generated.
Sorry, so the hash it goes to a random position in the hash table based off of just the mathematical formula that you put in the hash table.
Okay, so
for the hash function.
So
right?
if I made a hash, like if I try to make one, and instead of randomly generating a position, it just kept like sorry, I can't think very good because I hadn't slept in a long time.
Maybe sleep before the exam.
actually, I slept really well last night, but like the few days before that, hadn't slept very good. Anyways, so if I made like a hash table in quotation marks, I'm not sure if this would actually count. And instead of putting in the random position, it just puts it one after the other.
Ooh.
Would that count? That counts hash table?
Oh, so you would have, it would always go to, now the question is, how would you get it to the, so if I send the same object back in and ask where it goes, how would it know to put it right back into that same position?
Sorry, what?
So I add an object A to the hash table. Then I add B and C, let's say 2 other things. And then I say, hey, give me A back again. How would it find where A's position was? It doesn't know the index that it's being stored in. It just knows that you're looking for A. You cannot linearly search the hash table. The idea is you pass in A, I know exactly where it goes. So when I bring a library into the library, a book into the library, I don't go book by book looking for the book in the library. I have a particular number where it goes, the Dewey Decimal number, right? Please say you guys know the Dewey Decimal System, otherwise I'm really old, right? So if I go into a library and I look for a book, I know exactly where it is. I have a lookup. The name of that book tells me, or something about that book. Normally it's an ISBN number or something like that. But something about that book uniquely identifies where it goes in that library, and you go directly to that position in the library. You don't have to search for it. You just find it. That's what a hash table is. So you'd get the same. And Emily, I cannot respond to whoever else is talking there. So I also got to answer this crazy long list of things that are coming down here. So the idea of a hash table is it gives you a quick lookup. Now, if you said you just put it in the position, like each one of them has a number, and you put it the position where that number is, that would be a perfectly fine hash function. It may not work well. Or if I put them all at position 5, let's say I have a hash function and every single thing that I try and put in my hash table goes into position 5. What would that do? Well, it'd be a crappy hash table. That's what it would do. It's here.
Oh no, I'm just typing, but yeah. No, I was just trying to reply to on a chat saying like I also did horrible in the beginning too. I improved during the course, but I still have a long way to get the mark I wanted.
It's hard, and it's different people are coming at it from different terms and other versions of this course. For 1400 at least.
Because my last technically programming course was D3. And, yeah, so it's a little off and a little different.
Oh, it's a lot different. And but so, before that, you did the 1400 that didn't even do structs, right?
Yeah, we didn't. We only learned pointers for like five weeks, like continuously. It was just pointers. Like the professor that substituted our actual professor was like, so I don't know where you guys are, but I got pointers as my slide here, so we're going to do pointers. And we never actually learned a thing. So our last exam for that course was like 38 multiple choices. That's it.
I talked to some of the other students, and some of them, there was one student that finished the exam and had to wait for 15 minutes in order to get because there's a 20-minute window where you're not allowed to leave the exam hall.
30-minute where we can't leave, like in the beginning, and everyone in my course, at least that time, we finished within the 15 minutes because it was the multiple choice was the only thing on the exam.
Yeah, I'm trying to avoid that.
That's why when my first exam literally brought my whole entire mark down. Like I'm trying to catch up with trying to cover up my ass from there.
Exam 1's only worth 5%, right?
Yeah, not exam, the assignments. The first couple
we're dropping an assignment as well.
So yeah.
I'm expecting growth. I'm not anyone who thinks that you're
I was looking at my the last couple of assignments. I was like, oh, I finally improved but I still got a long way to do. So
I'm nothing but impressed with how much progress so many people have made. And I pushed people a bit too hard. I panicked a bunch of my grad students this afternoon when I went off on a rampage on them about the quality of their work, because the iTech, is it DS or iTech 2100?
for ours is upload. It's always iTech.
It's iTech. Okay, so the iTech 2100 projects that I got last term were better than some of the grad projects I got, and I went off on them. I just went off on them. I was like,
Yeah.
and they all started panicking. I have high standards. I'm sorry, but I get great. We have great students at the end, which hurts like
Yeah.
hell for the people that have trouble. But I mean, and it's really hard this particular term because of the pandemic. I can't do the not hand holding is not the right term, but like normally I'd have office hours and I'd be helping people after class, and we'd be doing things in the lab, and we'd be doing a lot more calming down of nerves and stuff. I also think my assignment 1 is not going to be looking like that ever again, because I wanted it to be like a take this seriously, and it went too seriously for most people, and that's all on me. Yeah, if you're doing poorly at the beginning, I'm expecting learning, not necessarily perfection when you walk in. But yes, I went too hard at the beginning, and then it's a matter of there's some flexibility that instructors end up having when it comes to where grades land. Let's say, like, it happens that if most people landed at an 89, maybe an A- goes down to an 89 now. Like, you can do a little. We got some extra little levers we can pull. I want to see what other comments we have, because this is yeah, the beginning does not tell you anything about how well you're doing. I think that you can have us, God knows my entire career is me screwing up, falling on my face, dusting myself off, going again. That is what university is all about. So sorry for the heartache initially, but doing poorly on exam 1 does not indicate that you're going to do poorly on this exam. It's impressive that you guys are coming back so strongly. All right. Yeah, we're waking. Sorry, I'm looking at this is a lot of. Is there something I really need to pull out of here? Because there's a lot of chat here.
Pandemic was hard.
Yes.
I found like in 1400 I was doing so well that even though my marks really dropped off at the end, I still ended the class with an A+. It was my best class. And it was the last couple of assignments, because they were all like during April where we were locked down. Like, I've been taking it pretty seriously, so I haven't been going out as much and stuff, and it's been taking a toll on my mental health. So like my ability to focus, to like really take in the lectures, or to like process the problems while I'm working on the assignments, it plummeted. And because I had mostly like 100s in all of the assignments until then, I got to drop my worst marks at the end. And so I still ended up with an A+, but I didn't really absorb a lot of our last lessons, particularly strings. And so when we went into this term, we started off with that, and I was still like getting used to doing a full workload during the pandemic. Like, I was still doing classes during the summer, but it was like 1 or 2 at a time. So it was very undemanding, and getting used to sitting down and like studying again and working on things sooner. It like my first assignment, I got a 38, and
Wow.
it got better after that. Like, I started being able to just power through this. It's still not like ideal, but I am
definitely
back
not
up to getting 90s in the assignments.
It's definitely not ideal. I will say
Yeah.
though that this caters to people that are not me. Let's just say I'm easily distracted. I will also say that, and you can read through the line between the lines all you want on that one. That is actually one of the challenges that this thing has brought, which is it requires this dedication that is very hard to do, and I have a really hard time with it as well. The dedication of planning out your schedule, putting in there slotting in a time to watch your lectures. If this is for future classes even, right? Slotting in the time to watch things, slotting the time to do this, that, and the other thing, rather than waiting until later and then figuring it out, right? And that's
Yeah.
been a lot of the, I've had people tell me, I didn't watch your lectures, but I watched some lectures online. You're like, no, you have to watch these. Even if you only watch it once and then you find someone better, that's fantastic. But my exams are based off of what I'm saying, not what somebody else online has said. And therefore, you should at least know what I've said. And
Oh,
that's really hard to do. It's hard to show up to class, force yourself to show up to class. It requires a dedication that I needed when I was doing sports. Yes, I actually at some point in time did sports. I was a competitive swimmer. There's no way in hell I'm jumping into the water at 6 o'clock in the morning without a coach yelling at me. That's just a coach yelling at you is a very different thing than doing it yourself. And you're doing it yourself during the pandemic, and that's hard to do. That's why we have, by the way, if you didn't know, we have compassionate grading. So
yeah.
if I don't know if that's been made a big deal of that or not, but it's officially passed. So if you fail, you can say it's a not unsatisfiable grade rather than lowering your GPA. If you get a C minus, you can say I want to take that as a satisfactory grade and not ruin your GPA. You get an A though, you can say, hey, I'm taking the A, right? It allows you a lot more flexibility. It means some people might get through when they shouldn't, but I'm okay with that. But it just, that might be future instructors' problem if people get through with, cheating or whatever the case is. But I think we're trying to make it as, it's not going to be easy, but we're trying the best we can. No one has ever gone through, there's maybe 200 people alive, maybe a bit more than that, but very, very, very few people on the planet Earth have gone through this sort of thing at all. Like with a global pandemic, that doesn't happen.
Yeah.
Right.
One of the big problems I found was, for one, we don't have to, because there's almost all of our lectures had at least an asynchronous option. It was very easy to just sleep in. And especially I found if I'm not exercising and I'm not going outside, I started exercising because I needed to, because if you just sit in your chair all day, it's really terrible for your physical and mental health. So that was actually that was actually something that I actively started doing to improve my school life. But it's also I am still sleeping in, but at least I can fall asleep at night. I was actually at a point where I could not sleep at night, and I'd get a few hours of sleep and then it would be time to get up and work on school stuff, or I would just sleep in if I had the option. But
I think
everything
sorry
the other issue is when you have that brain fog, if you have poor mental health and stuff, everything starts to take longer. So the time you slot in for your assignments might not be the time that you actually need to finish it. And even if you do have the extra time, you start working a bit later into the night, it starts interfering even more with your mental health. And
it requires a level of dedication that's really hard to do. But even your professors are panicking as well. They're calming us down constantly. It's okay. It doesn't have to be perfect, but it needs to be perfect. I think I'm the only one that doesn't care if it's perfect necessarily. But there are people, they're doing crazy number of hours. But I think I was going on 5 hours of sleep for the entire term. I may have given myself a health scare as of last week. Seriously, oh my, not good health scare. So yeah, it's not been good for anyone right now. You have I have all sorts of sympathy for students. My only issue is I also see the other side of things where we 1400. I can't see much.
We need a certain level of quality to get us through. If we don't have that, then
And
you get in trouble and we get in trouble.
I have no problem with even lowering the quality a little bit, not a problem at all. The problem is when people cheat to try and pass through without doing the work at all. That is where I get really crabby, right? If it's just you got a 48, you struggled, but you're trying and it's clearly that you're around the right idea, I'm okay. But if it's one of those like you grabbed it from Stack Overflow, stuffed it on the final exam, I get really pissy. Like,
Well, when we graduate, we still have to like be able to do the stuff that our jobs demand. So,
Mhm.
and granted, a lot of IMD students might not do a programming oriented job, but I mean, after the pandemic, we're still going to have classes that require that stuff. So
I would say either IMD or IRM or MPD. All of you guys, we're getting distracted by shiny objects here, but from my perspective here, the hardest thing in the world for you guys to get a job in is if you go leaning heavily into the artsy side of things. If anybody and their dog could do it, or there are people that it's hard to tell what quality is necessarily, it's really hard to make a living as an artist. If you can be an artist and a programmer, or have that wear both those hats properly, it's exceptionally hard to do. And if you can do that, there's a place for you. You're a unicorn, essentially. If you're just an artist that sort of fakes a little bit of programming or fakes a little bit of computer science, then how many other artists are graduating every single year in every other university on the planet? Right. That's where I'm always aiming it, right? That there's a special weird niche that you need to be able to speak both languages. And if you can, it's a rarity, and it's a gift, and it's something that you can really lean into. It's what I mean, I've been trying to lean into that my entire life. I'm a computer scientist, but also I deal with human factors all the time. So sort of psychology, computer science.
I do feel like if what you want to do is art, you should have gone into an art program. Like
Pure art,
I am
yes.
from the art side of things, but like I came in here knowing that this would help me learn how to program and stuff, and that was intentional. If that's all you want to do, you should go into a program that focuses on that, because you'll be a lot better at it if you just focus your time on the particular thing you want to do.
Yeah, but they also get wooed by the look how much more money you make if you're a combination of the two versus if you're a pure artist, because you do make more money.
But you need to secure work to make
What?
money. So
like there's a lot more money in it as a programmer than, I mean, I
Yeah.
took a huge pay cut being an instructor, just letting you know. I mean, it's the Google was paying a lot more than any university is going to pay. You do it because you like teaching, but not necessarily because, so there are certain jobs, if you want to be a programmer, if you wanted to have an artistic flair, then talk to programmers. There's a lot, you can demand a lot more money in terms of a final salary as well. But I'm loving the chat on the side. I wish I could answer or address all of them, but I love all well, maybe not the 3-day migraine, because that sounds like absolute hell. Sorry, my apology, my sympathies. Although I've been hitting my own number of migraines this entire term because of lack of sleep as well. But okay, it's 6:02. I've already got an hour over. I apologize. It's all going to be recorded. It's all going to be put online tonight. Can I help anybody else with anything else, or are we good to go? And I will see you guys tomorrow. I'll do the Discord thing we did last time. I hope that worked well. Just as a hey, this amount of time has passed, and we should be good. All right.
I usually mute Discord, but it could be useful for the kinds of questions that people put their hands up for in exam hall. Like, what does this question mean? Or
it's motion though.
like
if you have it pop up on your screen, it's pre-attentive.
Yeah. I actually I always set myself to do not disturb for exams because I don't want to be distracted.
Okay, then that's also a perfectly valid thing to do. It's just some people have trouble keeping track of time. So whatever works for you. If you you want to use Discord, put do not disturb. Give yourself an alarm clock. Put it right down. Just make sure you keep track of time. It's 3 hours. You have lots of time, but you don't want to lose track. All right, everyone. Thank you very much. I will talk to you. We'll send off some Discord stuff tomorrow, and good luck on the exam. You'll do fine. The people that are here, I'm not worried about, so you'll do fine. Good luck, guys.
Thank you.
Bye.
I hope you do well. Good luck. Goodbye.
Bye.
Good luck, everybody.